All right, so this is going to be an introduction to our waves worksheet. So a brief intro as of what we should do. At this point, everyone should have the wave worksheet in front of them, and we are also going to need a ruler for this assignment. And I would also highly suggest taking out your PowerPoint notes that we took on waves and wave properties. So this worksheet's going to have you work through a lot of that vocabulary from the notes, as well as our practice problems that we covered yesterday. So if you were absent, you will also want to make sure you get a copy of these notes from the absent bin. But everyone should have a ruler, and we are going to be working with the centimeter side of the ruler. So if your ruler just has inches, we'll need to pause the video and make sure too that everybody has a ruler with centimeters on it. So for this particular page, you are given a brief description of some of our wave properties. So a quick recap: amplitude is the height of the wave or the displacement of the wave from rest, how far it is. If there was no energy in the system, we would have no wave. This would be a flat line. So when we put energy into the system, that creates a wave. The height of the wave is related to how much energy that wave has. So higher wave, more energy. The wavelength is the length of a single wave cycle. So the length until a wave repeats itself. And remember, we can measure that from crest to crest, the two high points. We can measure that from trough to trough, the two low points, or from the equilibrium position to where it starts again at the equilibrium position. So I wouldn't stop here because this is only halfway through the cycle. I would measure wavelength from where I start to go back up into a crest again, because that's when the wave starts to repeat itself again. Waves are rhythmic, they're repetitive. And then the frequency is the number of waves that pass a given point. So typically when you're given a diagram and you're shown how many wavelengths are present, that generally, unless you're told otherwise, it represents a second's worth of time. So to find the frequency, typically all we need to do then is count how many wavelengths do we see. And then to solve for speed, you'll take wavelength times frequency, so lambda times f. So first we're asked how many wave cycles are completed in this diagram. So how many wave cycles? That's the frequency, number of waves that I see. So I see 1, 2, 3, 4, 5 wave cycles in this diagram. The wavelength, I'm going to actually measure how long the wavelength is. All I have to do is find one wavelength, and since they're rhythmic, they should all be the same length. So I can either measure from where I go into a crest to where I go into a crest again. I can measure from high point to high point, or I can measure from low point to low point, as long as I'm starting and ending at the same spot, so where a wave repeats itself. So I'm just going to do crest to crest. So I'll put the end of my ruler where the one crest is, and I'll measure until where that second crest stops. So that's about 2.7 centimeters. For this worksheet, you can give or take, a tenth of a centimeter here as we're measuring, and you go to check your answer. So if you put 2.6, 2.8, I'll let you have it. That's fine. Amplitude. So amplitude, that's the measurement of the displacement of the wave. So from our equilibrium or the mean position to the high point. I could also measure it from the equilibrium to the low point. So let's do that since the low point isn't covered by this little second mark here. So I can flip my ruler over. So it's a little over 1 centimeter. And put about 1.1 centimeters here. Frequency, so that's how many waves do I have. And so for this particular diagram, we did count how many wave cycles. We had 5. So that's another way of saying frequency. So here I can just rewrite 5. Frequency is 5 hertz, which represents how many waves we have in a second's worth of time. And then my speed, so that's wavelength times the frequency. So I can multiply 2.7 times 5 in my calculator equals f times lambda. Remember, our symbol for wavelength is lambda. Symbol for frequency here is f. So when I multiply these two together, you get about 13 and a half. And our units are in the meters form, just in centimeters, but we do have our speed in the appropriate metric units. So in this particular case here, then we're all done with this assignment. I'm sorry, in this section. And so what you're going to do now, obviously, is complete the rest of these questions. When you're done, you're going to get this assignment checked in, and then you'll see posted in Google Classroom an answer key to this, so you can check all your other answers as you go and make sure you're on the right track. After you've checked the answer key, hopefully everything makes sense. If you happen to have something wrong, if not, definitely send me an email and we'll go over it together when I have time. I'll send you a reply back. And then you have a short homework assignment afterwards posted in Google Classroom as well. It's a Google form that has a recap of some of these practice problems. Now, I am going to grade it on accuracy. So you've had a chance to work through these. You've had a chance to check your work. So do take it seriously. Use your notes if needed. But you are going to be getting points for having correct answers when you submit it. And I do have a little tiered key there for you so you can see how many points you'll get based on how many problems you get correct. Any questions? Again, send me an email, but everything else that you should need today once you're done with this worksheet and you get it checked in can all be found in Google Classroom for our work for the day. Have a good day, and I'll see you all soon.